Hello, I'm Trey, and I'm here to tell you about assessment in the classroom today in gifted education and why it's wrong. I think that decontextualized tests are dumb, that they don't do anything for the student. It's just a wasted class period. And by decontextualized test, I mean like when you sit down, you get a piece of paper with like 20 questions on it. A lot of time it's multiple choice, and you just have to show what you know. Anyway, so decontextualized test, I don't think help the student because school is a place where you're supposed to be learning. And when you take a whole day just to figure out what you know, that doesn't help. And that's not helping the student learn. I think that there are better ways to do testing where you still get the point of testing across, which is to assess a student and what they know, but in a way that helps the student learn. I would like to propose almost all tests, if possible, be done through projects. Now, I understand that there are some standardized tests that just need to be done, like those end-of-year tests where you sit down and you show what you know on those days so that the state has some data on your school. I can kind of understand that. But I don't understand why every unit we have to go through the unit where we learn the material, have a review day for the test, and then we take the test. Like, that's not productive. I'd like to propose that assessment be taken through projects, if possible. And by projects, I mean things that are created by the teacher or the school where the students are showing their knowledge through some kind of project. For example, maybe they are supposed to design and execute an experiment in science, because projects, if you think about it, are more useful to the learner because they don't just require you to show what you know. You also have to create. Creation, synthesis, is the highest form of learning because you have to make some connections. I always like to go back to my example about when I had my students in IM2, they made a booklet where they had to explain how to solve different types of quadratic functions, and they had to do it in 4 different ways. And what that did was that made them create a quadratic function, but when you do that, you want the quadratic function to come out with solutions that are whole number solutions, and you want to make sure that this function does have solutions, like real ones. And as a result, that makes you think backwards and makes you think, all right, well, how is the structure of a quadratic function such that I can do that? And then you realize a few things. The x-intercept, if you put it on the x-axis, then you're going to have one solution, and that's going to cause problems down the road. So that's going to be an interesting finding. If you make your solutions one apart, as in like one of the solutions is 1 and the other one is 2, that's going to cause a problem when you put it into vertex form, because then you won't have a whole number there. It'll be like plus 1/2 or something. So that makes you think about how a quadratic is just laid out. And that, to me, is a much deeper level of understanding than any test I can provide, because tests is just like, solve this quadratic, and then they do, and then, you get your results back. Hey, they can do it, yay. But if they create something like a booklet, they have to do some writing, they have to think about how a quadratic works, they have to still understand how to solve all those quadratics, but they also have to write out their thinking about how to solve a quadratic. And because they have to write it out, it's more likely to be memorable because they have to first explain it to themselves about how they're going to explain what a quadratic is. And to do that, you have to be able to explain how to solve a quadratic, and that's very helpful, I think. So I think that projects are the way to go. And I do have some research, of course, to back this up. From Metajisk, Reflection and Assessment for Learning in Science and Enrichment Courses for the Gifted. Her study begins by stating that although an observed science course is offered for gifted students, they do allow students to view material that is not usually taught in regular classes. The methods of assessment are not suitable. In most cases, they only use summative assessments. Classes lacked consistent and thoughtful assessments. Metajisk promotes the Assessment for Learning framework, which employed project-based science classes for students. These were characterized by the use of authentic tasks that are performed in real or simulated situations. It allowed students to use higher order thinking. It was continuous, reflective, and allows students to compare differences in their own results versus their peers' results. The idea here is that learning is promoted through social interaction and conversations. Another important part of assessment for learning is the use of peer and self-assessment, which simply means that you allow the students to grade their own work or that of their peers. And this allows the students to be more involved in determining what quality work looks like. in her study, she emphasized metacognition, which is the knowledge and awareness of an individual's own cognitive processes. In order to become an active learner, she says, students first need to learn how to learn. Metacognition is brought about more when students have to engage in careful, highly conscious reflection. During the class for which the study was designed, assessment was essentially just a part of the class learning structure. During traditional classes, the class learning structure is such that learning comes first and then a formal assessment comes second, and the assessment is usually decontextualized. And they did not help the students learn. In this model, students engaged in a three-part assessment model. First, students engaged in the exposure stage, in which students were allowed to engage with the science content, they met with researchers, and they also conducted short inquiry activities. Throughout this stage, the students also would negotiate with the teacher and suggest assessment criteria for the following stages and for the peer assessment meetings. The second stage was the inquiry stage, where students developed driving questions that developed their investigations. They also designed and executed those investigations, collected data, and research. And students also would build models and representations during this stage. Towards the completion of this stage, they would have self-assessments and teacher assessments and peer assessments. So a lot of feedback in this process for stage 2. And then last was the summary stage, which was essentially when the students were allowed to present their project that they embarked on. The main point that I took away from this was that the method of assessment enhanced the students' reflection on thinking and metacognitive processes, and it was not a sit down, take this test. It was a project that accomplished the goal of assessing the students' knowledge, but it also allowed the learning process to continue. It was not a wasted class period. It allowed students to continue to engage in the curriculum while providing them with control, feedback, and reflection. Another source from the Journal of Secondary Gifted Education is talking about authentic assessments. Authentic assessments are assessments that engage students in real-world tasks and scenario-based problem solving, rather than the more traditional measures such as multiple choice, pencil and paper tests. Performance-based assessments are always open-ended, and they can be answered using multiple approaches. There are 8 defining characteristics of these kinds of assessments according to the authors, which include Moon, Brighton, Callahan, Robinson. The first is that these assessments always focus on the big concepts, not the trivial details, like remembering the formula or calling the definition of a word. They're always in-depth, and they lead to other problems and questions. They promote curiosity. They can be done in school safely and easily. 4 is that they focus on the ability to produce a quality product or performance and not just one single right answer. 5, they promote and display the student's knowledge and expertise rather than trying to focus on discovering what it was a student does not remember. The 6th is that a good authentic assessment always has the criteria known and understood by both the teacher and the student in advance, rather than a traditional assessment where the teacher makes it and they understand the requirements that you would need to pass the assessment. However, the student is kind of left in the dark until the actual assessment is given because they can't see the assessment. The 7th is that they provide multiple ways in which the student can demonstrate knowledge. And last but not least, the scoring is focused on the essence of the task rather than by what is easiest to score, i.e. a Scantron multiple choice kind of test. Good examples of authentic assessments are performances, projects, writings, demonstrations, debates, simulations, presentations, and other sorts of open-ended tasks. Although the last source I have, which is from Joyce Van Tassel-Bosca from the Journal of Secondary Gifted Education, is focused around language arts assessments. It still gets the point across that I've been trying to say this whole time. Paper tests suck. Van Tassel-Bosca says that, and I quote, standardized tests normed on typical populations tell us almost nothing about growth in learning for gifted populations unless they are off level. I assume this is because you can only do so well on a standardized test. I must again repeat what I said at the beginning. I think it's necessary to have one standardized test or so at the state level so that the education departments in states have real data for each school and each teacher, and these can be taken at the end of the year. But asking gifted students to repeatedly take standardized tests, Miss Joyce is right. This will tell you something you already know concerning gifted students, that they understand on grade level material remarkably well. Thus, alternative assessment tools such as performance-based assessments, or what we just call authentic assessments, or portfolios, like collections of the student's work, they're going to be more useful in gauging a gifted student's level of understanding than any standardized test that's given on grade level.